Dear students, welcome to my 7th class on Module 1 Laplace Transforms. In this lecture video, we're going to discuss about the convolution theorem and problems on the convolution theorem. So first, we will learn the statement of the convolution theorem. The convolution is a way of combining two functions. It is defined as follows. If f and g are two functions, their convolution is a function defined as f star g or f into g is equal to integral 0 to 1 f of t minus u into g of u du. For example, the convolution of t and t square will be given like integral 0 to 1 t minus u into u square du. Like after solving this one, we'll be getting t u cube minus u power 4 by 4 with the limit 0 to t. So like applying the limit and simplifying this, we'll be getting 3 by 4 into t power 4. So now the convolution theorem of Laplace transform says that Laplace transform of f of t into Laplace transform of g of t will be equal to Laplace transform of f of t star g of t. The problems on convolution theorem. So first problem is verify the convolution theorem for f of t is equal to t and g of t is equal to e power t. So first we'll be finding the values of capital F and capital G by applying Laplace transform for the given f of t and g of t. So Laplace transform of f of t will be equal to Laplace transform of t. This will be equal to 1 by s square. Similarly, Laplace transform of g of t will be equal to Laplace transform of e power t, that is 1 by s minus 1. So therefore, Laplace transform of f of t into Laplace transform of g of t will be equal to 1 by s square into s minus 1. So now I am going to prove the RHS part. That is f of t star g of t I am going to consider. So f of t star g of t will be equal to integral 0 to t f of t minus u into g of u du. So now I will be converting this f of t in terms of f of t minus u, g of t in terms of g of u. So we will be getting integral 0 to 1 t minus u into e power u du. So here the t is a constant. After integrating this function, so we will be getting minus t plus e power t minus 1 after applying the limit. So now I am going to apply the Laplace transform for this equation on both the sides. So therefore Laplace transform of f of t star g of t will be equal to Laplace transform of e power t minus t minus 1. So by expanding this, we will be getting Laplace transform of e power t minus Laplace transform of t minus Laplace transform of 1. So this will be equal to 1 by s minus 1 minus 1 by s square minus 1 by s. So by taking LCM, we will be getting 1 by s square into s minus 1. So by combining these two, we can say that Laplace transform of f of t into Laplace transform of g of t will be equal to Laplace transform of f of t star g of t. So this formula is also can be written like Laplace inverse of f of s into g of s will be equal to f star g, or it will be equal to integral 0 to t f of t minus u into g of u du. So this formula will be applied to solve the problems in inverse Laplace transforms. Example number 2. Find the inverse Laplace transform of 1 by s into s square plus a square with the help of the concept convolution theorem. So now the first thing is we have to identify the functions f and capital G. So always we will be choosing the first function as f of s, that is f of s is equal to 1 by s, and g of s will be equal to 1 by s square plus a square. So now I am going to apply Laplace inverse for this f of s and g of s to find the values f of t and g of t. So after applying Laplace inverse on both sides here, we will be getting Laplace inverse of f of s is equal to f of t will be equal to Laplace inverse of 1 by s, that is 1. Similarly, Laplace inverse of g of s will be equal to g of t and into Laplace inverse of 1 by s square plus a square, that is sin at by a. So we got f of t is equal to 1 and g of t is equal to sin at by a. So now the formula I am going to apply here, that is Laplace inverse of 1 by s into s square plus a square is equal to Laplace inverse of f of s into g of s will be equal to f of t star g of t, that is integral 0 to t f of t minus u g of u du. So after replacing this f function and g function, we got integral 0 to t sin au by a into du we got. The constant 1 by a I am taking outside, integrating sin au with respect to u and applying the limit. We got 1 by a square into minus 1 minus cos 80 is the required solution. Example number 3. Find the inverse Laplace transform of s square by s square plus a square into s square plus b square, where the condition is b is not equal to a. So this problem is the same like a previous problem only. So first we need to identify the values of capital F and capital G. So here f of s will be s by s square plus a square. G of s will be s by s square plus b square. So applying Laplace inverse for these two functions on both the sides. So we'll be getting Laplace inverse of f of s is equal to Laplace inverse of s by s square plus a square. Laplace inverse of g of s is equal to Laplace inverse of s by s square plus b square. So this will be equal to f of t is equal to cos 80 and g of t is equal to cos bt. So now according to formula, I'll be converting this f of t as f of t minus u, g of t as g of u. So we'll be getting cos of 80 minus au and cos of du. So now taking the formula, Laplace inverse of s square by s square plus a square into s square plus b square will be equal to Laplace inverse of f of s into g of s will be equal to f star g. It is nothing but integral 0 to t cos of a into t minus u into cos b u du. So now to expand this one, I am going to use cos a cos b formula. So after applying the formula, we got the equation 1 by 2 integral 0 to t cos of at plus b minus u into u plus cos of at minus b plus a into u into du. So after integration, we got 1 by 2 into sin bt minus sin at divided by b minus a plus sin bt plus sin at by b plus a after applying the limit. So by taking LCM and simplifying further, we got the equation like 1 by b square minus a square into b sin bt minus a sin at is the required solution for the given problem s square by s square plus a square into s square plus b square by using the convolution theorem. Okay, in the next lecture video, we'll be discussing about the applications of Laplace transforms. Thank you.